With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question states, consider the situation of the previous problem. Consider the fastest electron emitted parallel to the large metal plate. Find the displacement of this electron parallel to its initial velocity before it strikes the large metal plate. So this is a part of the previous question, and in the previous question we were told that we have a small piece of cesium metal which was kept at a distance of 20 centimeters from any metal plate. A light of wavelength 400 nanometers struck this metal surface, cesium metal surface, and we know whenever light strikes any metal surface, electrons are emitted, and those photoelectrons will come out, and at some point of time they would strike this metal plate. So we need to find the displacement of the electrons that are being emitted parallel to its initial velocity before it strikes the large metal plate. So we need to find that displacement that this electron, that this photoelectron covers before it strikes the metal surface. In the previous question we were told that sigma, that is charge density, is equal to 1 into 10 to the power minus 9 coulomb per meter square. This was also given, and S is also given. So let's first calculate the electric field. Now see, why we are calculating the electric field. We know we need to calculate distance, that is S, right? So that would be V into T, right? Vertical velocity and the time it takes. Plus, for that thing we need to calculate acceleration, and acceleration can be calculated from force. And what is the force here? Electrostatic force. So we can write that force as ma, and for electrostatic force we need to calculate electric field. So E is equal to sigma by epsilon naught, which is a constant electric field. This is a constant electric field. Sigma is 1 into 10 to the power minus 9. Epsilon naught is 8.875 into 10 to the power minus 12. This comes out to be 113 volt per meter. This is our electric field. Now A is equal to, acceleration is equal to F by m. Force on this electron will be Q, charge of electron, into electric field, right, divided by m, mass of electron. This is Q is, charge of electron is 1.6 into 10 to the power minus 19. E is 113. Rest mass is 9.1 into 10 to the power minus 31, right? That is equal to 19.87 into 10 to the power 12 meter per second square. This is our acceleration. Now we need to calculate the time, right? So for time we can simply use S is equal to ut plus half of at square, and initial velocity here is 0, and we can write it as t is equal to root of 2y. Y is the displacement and a is the acceleration, because that ut term becomes 0. And then we have displacement is here is 20 centimeters, or 20 into 10 to the power minus 2 meters, and divided by acceleration is 19.87 into 10 to the power 12. This comes out to be 1.41 into 10 to the power minus 7 seconds. Okay, and now we have to calculate velocity. Velocity we can calculate from Einstein's photoelectric equation, that is kinetic energy is equal to energy of the photon minus work function, that is phi. And this we had calculated in the previous question. We can calculate it here also, and it comes out to be 1.2 electron volts. But like we need everything in SI units, so we can calculate this in joules. That is 1.2 into 1.6 into 10 to the power minus 19 joules. Okay, so this is our kinetic energy, and we know kinetic energy is 1 by 2 mv square. That is this 1.2 into 1.6 10 to the power minus 19. From here we'll get v square is equal to 1.2 into 1.6 to 10 to the power minus 19 divided by, we have mass into 2, and v comes out to be 0.665 into 10 to the power minus 6. M is 9.1 into 10 to the power minus 31. Minus 6 meters per second. So this is the velocity. Now we need to calculate the horizontal displacement. That is simply S is equal to V into T. And that is V is 0.665, because we need to calculate the displacement of the electron parallel to its initial velocity. That would be horizontal displacement. That is equal to 10 into 1.4 into 10 to the power minus 7. Time and velocity. That is equal to 0.092 meters, or we can say S is equal to 9.2 centimeters. So this is the displacement that it would cover before it strikes the large metal plate. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.